All right, these notes are going to be on multiplying and dividing rational expressions. So first we're going to talk about multiplying and then we'll talk about dividing. So starting off with a pretty simple kind of example, because I know you've multiplied fractions before, that when you multiply fractions, you have to go straight across. So 2 times y is 2y, x times 5 is 5x. So our note to ourselves is that when we're multiplying rational expressions, we do multiply straight across. Now this is an advanced math class, so of course we're not going to do super simple examples like that or problems like that all the time. We do have to do more complicated problems. So for our next problem, we're going to do 3x divided by 5 multiplied by 30 over 18x squared. Now there's two different ways to do a problem like this. One way is you could start from the beginning and just go straight across. 3x times 30 is 90x. 5 times 18x squared. 5 times 18, I believe, is also 90. And then you could say 90 divided by 90 is 1, so those would completely cancel. There's an x on the top and an x on the bottom, and so we would end up getting 1 over x. So whenever you have these problems where you have a monomial over a monomial multiplied by a monomial over a monomial, you can go ahead and just do that, where you multiply straight across. I don't like to do this. Well, this one worked out nicely, 90 over 90, but sometimes they don't. So what I typically do is I reduce the problem before I multiply, and that way my numbers don't get very big when I do it. So I would say like, oh, 3 and 18, those can simplify, right? And this is multiply and this is division, right? This is multiplication, multiplication, tops and bottoms would be division. And so I would say 3 divided by 3 is 1. 18 divided by 3 is 6. And then I would say, okay, the 30 and the 5, those can simplify a little bit. 5 divided by 5 is 1. 30 divided by 5 is 6. So I can see I've got x over 1 times 6 over 6x squared. And then I can see that those 6's cancel, and that 1x over here will get rid of 1x over there, and that my result is 1 over x. So either way you do it is fine, but you'll see when I do the work on my answer keys, I typically do this because the numbers, when they get big, they're not always pretty like this answer was. Sometimes when they get big, they end up being really messy problems. All right, example 2. We want to look at what happens if we have something that's not a monomial, because these are a little bit more difficult. They require factoring and a lot more complicated steps. So this is not a problem that you would want to like multiply out first. That would be terrible. So don't treat it like this one. Don't be like, oh, I'm going to multiply the tops and multiply the bottoms, because your answer is going to get super complicated and big, and then you're not able to factor it. So what we do with problems like this is we go ahead and we factor first. So for this one, I'm looking for two things that multiply to be -10 but add to be -3. So that would be -5 and +2. For the denominator, I'm looking for two things that multiply to be 15 but add to be 8. And so that would be 5 and 3. Over here, I'm looking for two things that multiply -15 but add to +2. 5 and negative 3. And then I'm looking for two things that would multiply to 14 but add to be 9, and that's 7 and 2. And since these are being multiplied together, you really could write this out as like one like ginormous fraction. And I'm going to go ahead and do that this time, but normally I wouldn't do that because it's an extra step that's not necessary. But if you're saying, yeah, to do multiplication, just multiply straight across the top and multiply straight across the bottom, then technically I could do this. So I have it all the tops have been multiplied, all the bottoms have been multiplied. And now I just want to see if there are any tops and bottoms that could divide to equal 1. So x plus 2 divided by x plus 2 equals 1. X plus 5 divided by x plus 5 equals 1. It feels like the 3's should go away, but they won't because they're not the same. We've got a minus and a plus. And so that means that our final answer is going to be x minus 5, x minus 3, over x plus 3, x plus 7. And most people would leave it in the factored form, but if you wanted to multiply those out, like FOIL those out and say it was x squared minus 8x plus 15 over x squared plus 10x plus 21, that answer is just as accurate. Those are both good answers. Okay, let's do one more multiplication problem, and then we'll talk about division. So for the last multiplication problem, example 3, we're going to do 10x squared plus 70x divided by 36 minus 6x multiplied by x squared minus 2x minus 24 over 10x squared plus 40x. And so in this problem, this is GCF, GCF. This part right here is written backwards, if you can see, 36 minus 6x. So I'm going to go ahead and switch that. That's negative 6x plus 36. Okay, and now I'm going to go ahead and start factoring. So on the top, I have a GCF of 10x, and that would leave me with x plus 7. On the bottom, so now that we have it written in the correct order, we do have a negative in the front. And if you guys recall from the simplifying notes, if we have a negative in the front, we should take that negative out with the GCF. So I'm going to factor out a negative 6, and that would leave me with x minus 6. And then over here, we're looking for two things that multiply to negative 24 but add to negative 2. And that would be negative 6 and positive 4. So x minus 6, x plus 4. And then here we have a GCF of 10x and then x plus 4. Okay, so you can do that step if you want, where you write it as like one big fraction, but you don't need to. At this point, I'm going to look for things that divide to equal 1. So I have x plus 4 divided by x plus 4. That divides to 1. X minus 6 divided by x minus 6 divides to 1. 10x and 10x divide to be 1. And so I'm left with x plus 7 over negative 6. This is a great answer. You could say this is your final answer. Most math people would not leave the negative on the bottom. They would move it to the top. And they would say this is negative of x plus 7 over 6. Or they would distribute that negative and say negative x minus 7 over 6. Any of these answers is fine. All of those are right. But this answer is the one that would most likely show up on a multiple choice item. So just wanted to make sure we're okay with that. Okay, let's go ahead and talk about division. So with division, we would have a problem like 2 over x divided by y over 5. And what we do when we have a problem like this is we keep the first fraction. So I'm going to go ahead and write keep it. we change it to a multiplication problem, so we keep it, change it, and then the second fraction gets flipped. And so keep it, change it, flip it is how people often remember this. And then now that it's written like that, we can go ahead and just multiply straight across. So 2 times 5 is 10, and x times y is xy. So whenever we see a division problem, we're going to go ahead and do keep it, change it, flip it. Okay, so if I have, for example, 4, I have x squared minus 1 over 4x divided by x squared minus 5x plus 4 over x cubed minus 16x. Then the very first thing I'm going to do in the problem is I'm going to do keep it, change it, flip it. And I do that before I even start factoring, and I do that before I start canceling anything. Always do keep it, change it, flip it first. So now it has turned into a multiplication problem, and all I have to do is factor and then see what could cancel. So this is difference of squares. So I have x plus 1, x minus 1 over 4x. On the top, I can see that I do have a GCF of x, and then that would leave me with x squared minus 16. But that's not done factoring yet. Once you take out that GCF, you do have difference of squares left over. And so I'm going to take out that GCF of x, and then I'm going to go ahead and do difference of squares. So x plus 4x minus 4. And then on the bottom, we're looking for two things that multiply to 4, but add to negative 5. And that's negative 4 and negative 1. So x minus 4, x minus 1. Okay, so now I can go ahead and divide factors. So x minus 4 and x minus 4, those will cancel. X minus 1 and x minus 1, those will cancel. For those GCFs, the 4 on the bottom won't cancel, but there is an x and an x, and so this and this will cancel. And so that leaves me with x plus 1, x plus 4 over 4. And that is a great answer. Or if you want to FOIL out the top, you could say x squared plus 5x plus 4 over 4. So whichever way you want to write it is totally fine with me. All right, and then one last example. Example 5. X squared minus 1 over x squared plus x minus 12 divided by 3x minus 3 over x plus 4. So again, we start off by doing keep it, change it, flip it. So keep it, change it to a multiplication problem. Flip the second fraction. And then we're going to go ahead and factor. So on the top, I can see difference of squares. And then on the bottom, I'm looking for two things that multiply to negative 12 but add to positive 1. And that would be 4 and negative 3. And for the second fraction, I have a GCF of 3 that I can take out. All right, so x plus 4, those divide to make a 1. X minus 1, those divide to make a 1. And so we are left with x plus 1 over 3 and x minus 3. And you could leave the fraction like this, the rational expression you could leave like that, or you could say x plus 1 over 3x minus 9. Both of those are good answers.